Assalamualaikum warahmatullahi wabarakatuh. Good morning, dear students. How are you today? I hope you are in well condition. Although we're doing all activities at home, but you have to keep your spirit. Welcome to my course in Fun Science Learning with me, Sofi Alfiani, from International Program on Science Education 2017. Here we are going to learn about chemistry. Is it interesting, right? And then today's lesson, we are going to talk about chemical reaction. Did you know everything in the world is made up of chemicals? Chemicals can react with another to form new chemicals. But first, let me give you a few situations, and then you need to tell me that the changes that occur is it physical or chemical changes. First situation, the paper is torn, and in the second situation, the paper is burned, and then the third one is the water is converted into ice, and the last one is respiration process. Which one among those examples are included in the physical changes, and which one among those examples is included into chemical changes? To differentiate, you first need to know what is physical and chemical changes means. Physical changes is the process in which the substance experience the change in its physical properties like shape, size, appearance, or state, and there is no change in internal structure or molecular composition. Chemical changes that result in new formation of new substance, and truly the actives of one or more substance are rearranged and combined to form a new substance. So let's go back to our example. The first one is the paper is torn. Is it physical or chemical changes? Are we getting a new substance entirely, or the changes of chemical properties? Not at all. The paper just torn into two pieces of paper, but it's still paper, right? And nothing else. Hence, it's physical changes. So, what about the paper is being burned? The paper is converted into ash and smoke. The new substance is entirely occurred. So this is a chemical changes. So what about the water is converted into ice? Here, just the state of the matter is changing, which is the physical properties, while another is nothing changed. The ice can be converted into water bag with little bit of heating. Hence, its physical changes. The last one is interesting process, which is a respiration process. What happens when we respire? We utilize the oxygen we inhale, and then after the respiration process, we exhale the carbon dioxide, which is the new substance is formed, and hence is chemical changes. Whenever chemical changes is occur, there is chemical reaction, and this is what we will study in detail. What do we actually mean by chemical reaction, and how do we know that chemical reaction is taking place? All of this matter and much more we can learn in today's lesson. Okay, today we are going to learn more deeper about the chemical reaction. And here we have a presentation about the chemical reaction. So, what is chemical reaction? Chemical reaction is a process in which one or more substance, the reactant as we can call reactant, are converted to one or more different substance we call product. For example, hydrogen reacts with oxygen will produce water. Hydrogen and oxygen here as a reactant, and then the water here as a product. Water here as new substance with new properties. As we learned before, the chemical reaction is the reactions that form a new substance. Here, the water is a new substance with a new properties. So the example of chemical reaction in our daily life. Have you ever seen the rotten banana or the rotten fruit? And then the iron rust, after the iron is exposed to the oxygen, to the air, a long time, iron can be rusted. And then the campfire or another combustion process. Here, the wood will produce a new substance which is charcoal. It is a chemical reaction. And then the respiration process. In our body, there is a lot of process that occur chemical reaction. And then the digestion process. Digestion also
it is a chemical reaction because it is in our body react the another process that from the one substance into produce another substance in order to nutrients can be absorbed in our body. So the chemical reaction are described with chemical equation, which symbolically present the starting materials and reactant and sometimes intermediate product and reaction conditions. So the chemical equations is closely related into chemical reaction because chemical equation is written representation using number and symbol of the process that occur during the chemical reaction. So what happened in chemical reaction? In chemical reaction, two products react with each other to form a new product. To get understanding, this is in simple way. A substance A react with substance B can be produced substance C and then substance B. It is the simple way to express the chemical equation. So the chemical equation shows the overall chemical change of the reactant into the product. There are two ways to express the chemical equation. The first one is in word equation. For example, sodium hydroxide plus hydrochloric acid, which is produce sodium chloride plus water. And then the formula equation. Here, from the word equation, we can convert into the formula sodium hydroxide, which is NaOH, plus hydrochloric acid, which is HCl, produce sodium chloride, which is NaCl, and water, H2O. So here we can see the reaction about the respiration process. Here there is a reactant yield product or reactant produce product. Here the reactant is glucose and then the oxygen and then produce carbon dioxide and water. But there is a number in front of the substance. Here the number is called the coefficient, and the number after the number small here after the atom is subscript, and then here is the formula, as you know that. And then the arrow symbol here, it shows that the reaction is irreversible in the direction. And then before you learn about the chemical equation, before you learn about the balancing equation, here you should know the symbol of chemical equation. The first one is symbol plus. Symbol plus is used to separate one reactant of product from another. And then the arrow to the side is symbol to separate the reactant from the product is pronounced yield or produce when the equation is read. And then the arrow to the bottom direction is symbol that alternative way of representing a substance in solid state. And then the arrow is up direction. The symbol is an alternative way of representing a substance in gaseous state. And then the arrow here is symbol used when the reaction can produce in both directions. We call it reversible or equilibrium arrow. And then another symbol is S. The symbol indicates that the substance is in solid state. And then G, this indicates the substance is in gaseous state. There is two alternative way to express is the solid state and gaseous state. In the previous symbol, we know the arrow to the bottom and the up direction. And then the AQ symbol here, the symbol indicates that the substance is dissolved in water. And AQ comes from aqueous state. And then the last one is this symbol, L, indicates that the substance is in liquid state. So how to balance the chemical equation? To balance chemical equation, we conform to law of conservation of mass, and equation is called balance when the total number of the atoms of each kind are same on both sides of the atom. For example, we can see here the reactant of the methane, and then oxygen here will produce the carbon dioxide and H2O. We calculate the number of each atom. C here is 1, and then the H here is 4, and then the oxygen here is 4. It's 4 also. And then see the product. In the product, C have one number of atoms, and then O here is 2 plus 2. We have 4, and then H we have 2 H2, which is 4. It is a balanced equation. See another example: hydrogen plus oxygen in water produce water in word equation. But how in formula equation? H2, which is hydrogen, and O2, which is oxygen, produce H2O or water in formula equation. But is this already balanced? So let's see the first condition. We write the element here, H and O, and then the number of atom in reactant, and then the number of atom in product. Here, H2, we have 2H to the number of H, and then 2 number of O in the product. In the reactant, I mean. And then here, see the product here, the number of H is 2, which is already the same, right? But O, just 1. It's not balanced yet. How to balance it? To balance this equation, we have to add the number of O in the product. We have add to the number of coefficient here, because the O here is 1, so we write the number 2 here. So in order to the number of O is 2. It's already balanced, right? The number of O. But when we add the coefficient, not only O that increase, but also H increase. So how we can balance the H? We can add the coefficient of H in front of H2 here. So we see the number of H is 4, and then here in the product the number of H is 4 also. And then the number of O2 is 2, and here is 2 also. So after balancing, we can see that H is 4, and then the end product is 4 also, and then the number of O in the reactant is 2, and the number atom O in product is 2 also. So see the final equation. 2H2 plus 2O2 can produce 2H2O, and then it's a balanced equation. So another example, here I will introduce you to another symbol. In this equation, we can see the sodium in S, and then water in L, and then the sodium hydroxide in AQ plus, and then H plus AG plus. So what does it mean? S here is in solid state, and then water here is liquid state, and then the sodium hydroxide here is aqueous state, and then the H here, which is dissolved in water, and then H here are gas states. But there is another factors that increase the rate of the reaction. Here, as you can see here, potassium permanganate. But potassium permanganate here is up above the arrow. What does it mean? Potassium permanganate here in that equation as a catalyst that improves the rate of chemical reaction. So the factors that affect the rate of the reaction, the first one is the surface of area. The surface area of the reactant can be explained in another meeting, which is in a laboratory activity. And then the concentration of the reactant and gas pressure. The concentration, the rate of the chemical reaction will increase if the concentration of the reactant is increased too, because there are more particles unit per volume. And then the temperature, which the reaction is carried out. As the temperature increase, the reactant particles increase. The reactant particles increase their kinetic energy, and they are more faster. The faster the movement of the result is more collision between the particles. Some of these extra collision, which result from the temperature increase, and will be successfully collision because the reaction will be increased too. And then the light. Some chemical reactions are affected by light. For example, in photosynthesis process. When particles absorb light energy, the energy can be used to break the bonding, overcoming the activation energy of the reaction and cause chemical reaction to occur faster. And then the last one is catalyst. Over 90% of industrial process is catalyst. Catalyst is substance which can alter the rate of reaction without being chemical change itself. So catalyst here including the enzyme.
I already prepared the fact simulation of balancing chemical equation to enhance your understanding about chemical equation. So let we see the introduction first. In introduction, there are tools. The choices are non, with balance, and with the graphic, but we choose non in order to we see the molecular shape. So let we start the balancing process. We want to make ammonia compound first and as a product, and how much do we need the nitrogen or N2 and hydrogen or H2 as a reactant. We add until it balanced. We see still not balanced. We try again. Okay, it's already balanced. To make the compound ammonia, we need 1 and 2 and 3 H2. We try to separate the water. So from blah 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 water, we can produce how much H2 or hydrogen and O2 or oxygen. Same with previous, we try to balance it. From 2 H2O, we can produce 2 H2 and 1 O2. It's already balanced. And the last one is combust methane. Same with the other, the combustion involves the oxygen, therefore, and then the product of complete combustion are carbon dioxide and water. So we combust the methane with 2 oxygen, will produce 1 carbon dioxide and 2 water. Okay, let me see. So let's do the games. We have challenge 1 until 5, and the challenge to make equation balance. If it's not balanced yet, we try again until it's balanced, and we have to score and finish until challenge 5. We choose the level 1 first and try to balance the equation, the reactant, to produce the product. Okay, finish it until challenge 5. So if we finish until challenge 5, we start over, and then we can continue to level 2 and level 3 by yourself. If you want to continue the games of PET simulation of balancing chemical equation, you can click or scan the QR code in this video.
Now it's your turn. You can discuss with your group, but before you discuss with your group, you have to watch the video that I've already provided here, and then you have to download the worksheet in the link in this video, or you can scan the QR code in this video. After you download the worksheet and then watch the video, please fill the worksheet with your group, and then if you have finished, you can submit into my email. You can search in the internet to additional information to enrich your concept.
Here the summary for our lesson today. We have learned about chemical reaction, chemical equation, and how to balance the chemical equation and the symbol there. And then the last one is physical and chemical change.
Okay, maybe that's all for this lesson today, but I have evaluation to measure your understanding about how information that I've already explained to you. Please click link in this video, scan the QR code here, and then after you finish your answer, you can submit it, but it is individually, okay? Okay, the time is over, and then see you in another video lesson. Thank you for your all attention. Wassalamualaikum warahmatullahi wabarakatuh.